So dear students, welcome to the class. Welcome to the session of JEE Bytes. So I'm Ankit on behalf of Meritnation. I welcome all of you to our session of JEE Bytes. So today we are going to do the ray optics part. So hello, Maxus, Tushar, Harshit, Gaurav, Divyansh, and Sachin. Welcome to the session. So now let's begin with the questions of previous year JEE. So here we have a question in which it's being asked that a short linear object of length b lies along the axis of a concave mirror of focal length f at a distance of u from the pole of the mirror. The size of the image is approximately equal to. So here we are required to find the approximate size of the image. So how to find that? See what is given. What are the parameters that are given here? The parameters that are given over here are b. That means the length of the object, the focal length of the concave mirror, and distance of the object from the pole. So how to find this? How to find the size of the image, right? So firstly, we know that 1 by v plus 1 by u is equal to 1 by f. This is a mirror formula. So yes. So yeah, you're right, Sachin. In this question, if we know the magnification, we can find the size of image. So here it's required to find the approximate size of the image. So we need to find approximate, you say magnification, right? Now let's see. So we can also write this formula as v raised to the power minus 1 plus u raised to the power minus 1 is equal to 1 by f. So if you differentiate both sides with respect to u, so what do you get? If we differentiate both sides, what do we get? We get v to the power of minus 2 with respect to u. We are differentiating u. So v raised to minus 2 and dv by du plus u to the power of minus 2, and it's equal to 0 because f is a constant value. So yes, from this we can get one equation, that is v to the power of minus 2 dv plus u to the power of minus 2 du is equal to 0. Okay. So what do we get from here? We can find the value of dv by du from here. So what do we get? dv by du is equal to v square by u square, minus of v square by u square, right? Minus of, what we can do, we can take v to the power minus 2 dv is equal to minus u square into du. So dv over du is equal to minus of u to the power of minus 2. Wait. So u to the power of minus 2 and du. So what do we get from here? We get minus of u raised to minus 2 divided by v to the power minus 2. So ultimately it's equal to minus of v square by u square. Okay, sorry. So yeah, see, I have the negative sign I have taken to the right hand side because it's 0. Okay, Siddhant. So I've directly written that. Okay. So yes, we're talking about the magnitude part of dv by du. So that will be equal to v square upon u square, right? V square upon U square is the magnitude of dV by du. So what is this? Actually, this is approximate magnification. Right? So yes, this is approximate magnification. So dV by du, you can say it's equal to m. And suppose I is the size of image and O is the size of object, we can say I is equal to m times U, m times O, right? Where if I is what? Is the image size and O is the object size. So yes, next thing, what do we need now? We need the value of V square by U square. So in the question, what is given? V is not given. So we have to find the value of V. Or we can eliminate the value of V in terms of U and F. So yes, now it becomes M is equal to V square upon U square. And we can find the value of V square by U square by the simple mirror formula 1 by V plus 1 by U is equal to 1 by F. So from here, we can say 1 by V is equal to 1 by F minus 1 by U. Or we can say 1 by V is equal to Fu is the LCM, so U minus F. And if you want to find the value of V, that is equal to Fu divided by U minus F. So we can find the value of V by U from this. That's equal to F upon U minus F. So if you square both sides, what do you get? You get V square by U square is equal to F by U minus F whole square. This is the formula for magnification. Yes, we have got this M is equal to V square by U square for the given question. So this is what? M. M is equal to image size by object size. In the question, it is given that object size is equal to B. So yes, V square, or you can say F by U minus F whole square is equal to I by P. Or you can say I is equal to, or the image size is equal to B times F by U minus F whole square. This is the answer for the given question. So yes, let's move to the next question. This is the question that is that came in JEE, and this question also appeared in AIMS also, right? So yeah, this is the correct answer for the given question. Okay. So the other question, this is question of JEE Advanced 2014. A point source S is placed at the bottom of a transparent block of height 10 millimeter and refractive index 2.72. It is immersed in a lower refractive index liquid as shown in the figure. If you observe the figure, you can see that this is the block and this is the liquid. So it is found that the light emerging from the block to the liquid forms a circular bright spot of diameter 11.54 millimeter on the top of the block. The refractive index of the liquid is. So first of all, we should understand that this is a block, and block is made up of some transparent material. Transparent material means that light can travel through it, right? So now if you observe this, what is the reason for a bright spot? What do you think is the reason for a bright spot? Yes, why there's a bright spot in the middle of the block? Suppose this S is a source of light. This S is a source of light. So why a bright spot is being formed. I'm asking to all of you. You can see that if light goes from this block outside, it will refract. Yes. And this block is having, more refractive index as compared to the liquid. So that means the bending will be away from the normal. The bending of light will be away from the normal, right? So why we are observing a bright spot? The reason is the total internal reflection. Because after that, after this you say, after this point, all the light rays are getting reflected. So now they're not getting transmitted. So till this point and this point, the angle of incidence is equal to angle of, or you can say critical angle. Up to the bright spot, we can say, up to the periphery of bright spot, we can say that the angle of incidence is equal to critical angle. Okay, critical angle. Meghna, it's not the water. We have to find the refractive index of the given liquid. It cannot be any liquid. So how to find the refractive index? Let me draw a diagram again. Suppose this is a point source, and it's emanating light rays, and these light rays will be, refracted in such a way that the angle of refraction becomes 90 degree, right? So okay, so yeah, so this angle is the critical angle, IC, and the refractive angle for the angle of refraction for this is 90 degree. Okay, now if you draw a line parallel to the given line, you can say that this angle and this angle, they're equal because they're alternate angles. So this is also equal to IC. So can you find? Okay, wait. So first of all, we will apply Snell's law here. So what is the refractive index for the given medium? It's 2.72. Let us say the upper medium or the liquid is having refractive index of mu. So 2.72 times, applying Snell's law, 2.72 times sine IC is equal to mu times sine of 90 degree. So from this, I can say that if I find the value of sine IC, I'll get the value of mu, 2.72 times sine IC. That's the value of mu. So how to find the value of sine IC? This is completely the question of geometry now. So yes, given that this complete, see, the bright spot is of 11.54 millimeter in diameter. So the diameter of the bright spot is 11.54 millimeter. So we can say its radius will be equal to half of that. That's equal to 11.54 divided by 2. And the distance, or you can say the thickness of the block, is 10 millimeter. So yes, this is 10 millimeter. So from this, we can find the value of sine IC, because this is what? This is your, if you talk about this triangle, let's say triangle OAB. So in triangle OAB, if you talk about, OA is the, you can say, is the base, AB is the perpendicular, and OB is the hypotenuse, right? So we can find the value of sine IC. How can you find that? Sine IC is equal to, sine IC is equal to, you say AB over under root of, or you can say AB over OB, right? So how can you find the value of OB? OB is equal to under root of AB square plus OA square. Yes. So ultimately sine IC is equal to, it's equal to 11.54 over 2 divided by under root of 11.54 over 2 whole square plus 10 square. So just a very big expression it has come, but it was a question of JEE advanced. So we can calculate that. It's not a very difficult thing to calculate. So yes, we can find the value of sine IC from this. So what is the value of sine IC? Just if you calculate, the value will come to be equal to 11.54 over 23.09. The denominator will come to be 23.09, right? So yes, from here I can say that sine IC is equal to 11.54 over 23.09. So ultimately we have to find the value of mu. Okay, so mu is equal to 2.72 times sine IC. So mu is equal to 2.72 times sine IC. So 2.72 times sine IC. What is the value of sine IC again? You can find from the previous slide. It's 11.54 by 23.09. 11.54 over 23.09. So it will come to be equal to 1.36. Okay, that means the correct answer or the given question is C. So now let's move forward to the next question. So the question is, a ball is dropped from a height of 20 meters above the surface of water in a lake. The refractive index of water is 4/3. A fish inside the lake is in the line of fall of the ball is looking at the ball. At an instant when the ball is 12.8 meters above the water surface, the fish sees the speed of the ball as. So what we have to find? We have to find the speed with which the fish observes the ball. A ball is falling and a fish is observing from the lake, from inside the lake. So you have learned that apparent height, the concept of apparent height. What is the apparent height? If you observe, let's say above medium is air and you're observing from here. So this height will appear to be equal to mu times, let's say this is x, so it will appear to mu x. So mu x is the height of the, you can say, apparent height. Now let us find the real speed. Okay, see if the speed is, if the distance is x, the apparent distance is mu x. If you have to find velocity, you have to differentiate this. So dx by dt, and the apparent velocity will be mu into dx by dt. So whatever velocity comes, just multiply with the value of mu. You'll get the value of velocity of the ball as observed by the fish. So yes, read the question again. So ball is dropped from 20-meter height. Okay. The fish inside the lake in the line of the fall of the ball is looking at the ball. At an instant, the ball is 12.8 meter above the water. So this distance is 12.8 meter. So we have to, okay, now the ball is being dropped from a height. This height, see, this height is 20 meters. So the ball has reached the distance of 12.8 meters. So what is the distance? This is the distance traveled by the ball. So how to find that? 20 minus 12.8. So you can find that the distance is 7.2 meters. So we can find the value of the speed at the given point. How can you find that? Simply applying v square minus u square is equal to 2as. So what is the value of u? U is equal to 0 because the ball is dropped. So v square is equal to how much? It's equal to under root of 2. What is the value of a? A is equal to g. Okay, so let us take g to be 10 into 10 and height is 7.2. So if you solve it, you'll get it to be equal to 14.4 into 10, and that means that's equal to 144, and this is the value of v naught v square. So v is equal to 12 meters per second. This is the value of velocity of this is the real velocity of the ball at the given point. So multiply this velocity with the value of refractive index, you'll get the value of the apparent speed as observed by the fish. So yes, what is the value of that? Given that it's 4/3, so apparent velocity is equal to 12 times 4/3, and that's equal to 16 meter per second. That is the correct answer for the given question, and it is option C. That is correct. Let's move forward. Now, the next question. A ray of light is incident at the glass-water interface at an angle of I. It emerges finally parallel to the surface of water. Then the value of mu g, or the refractive index of glass, is. So how to solve this question? These types of question, even though there can be n number of media. For example, after glass, there's water. There can be other media also. So in that situation, in every situation, we have to solve this question using Snell's law. It's very simple, very basic thing. Suppose mu g is the refractive index of the glass. So we can say mu g times sine I is equal to, it's given that mu w is the refractive index of water. So mu w times sine r. Okay, simply. So mu g sine I is equal to mu w sine r. Okay, for the next surface, for the next interface, we can say this r becomes the angle of incidence, and the angle of refraction is 90 degree. So we can say mu w into sine r is equal to 1, because air's refractive index is taken to be 1. So 1 time sine of 90 degree. So if we take this equation 1 and this is equation 2, so from both the equations we can say that mu g sine I is equal to 1. So this means mu g is equal to 1 by sine I. So this is the correct answer for the given question. So the correct answer is B. So in this way, I would like to inspire you all to solve more questions so that you can actually do good in JEE mains as well as advance in your future. So thank you so much, students, for the session, for coming in the session. So to know how Meritnation can boost your preparation for JEE 2019 with Power Pack Premium courses, go to this URL and send us your details. So thank you so much, students.